Hello friends, this is your friendly neighborhood explainer Kuro. In 1946, Paul Erdős asked one simple question. This May, an AI proved him wrong. 80 years is long enough for a probably true guess to start feeling like settled fact. Erdős's unit distance conjecture sat exactly like that, widely believed, never actually nailed down. Then, this May, it just stopped being true. Here's the plain English shape of it before the real math. Scatter some points on a page. Draw a line between any two that sit exactly 1 unit apart. Erdős's question: as you add more points, how fast can those unit length connections pile up? He guessed, barely faster than the points themselves. Almost a straight line, growth-wise. Formally call in the most unit distance pairs you can pack among n points. Erdős' conjectured domain never exceeds n to the power of 1 plus c over log n. Log n grows unbelievably slowly, so that ceiling is barely above a straight line. A near linear ceiling believed for 80 years by the best mathematicians alive? True or a trap? Guess before Kuro tells you what actually happened. Here's why nobody broke this for 8 decades. To disprove it, you need one explicit point arrangement that beats the bound for every possible c. That means inventing new geometry, not just searching harder within the old toolbox. The thing that actually broke this, an internal, unreleased OpenAI research model. It didn't just guess an answer, it handed mathematicians an explicit, checkable construction. This same model lineage is the one OpenAI would go on to publicly reveal as Astra. To beat a conjecture about points and distances, what field of math do you reach for? Take a guess. The real answer is stranger than combinatorics. Here's the actual left turn that made this possible. Unit distances live in plane geometry. The model reached instead into algebraic number theory, specifically infinite glass field towers and Golod-Shafarevich theory, machinery for number fields, not dot-to-dot puzzles. It stitched ideas from Golod, Shafarevich, Ellenberg, Venkatesh, and Hajir Maire Ramakrishna into a combinatorics problem. None of them were written for. Here's what that construction actually delivers. An infinite family of point sets in the plane, each one built using multiquadratic CM fields. For every single C in Erdős's formula, some point set in that family beats his bound. Not a one-off counterexample, a whole machine for generating them on demand. Here's how seriously the math world took this. Fields Medalist Tim Gowers said he'd recommend it for the Annals of Mathematics without hesitation. The Annals is about as prestigious as math journals get. That's not a casual compliment. The AI's construction was correct, but famously terse, not written for humans. So 9 mathematicians, including Gowers and Noga alone, rebuilt it into a paper humans could actually follow. That companion paper is the version the rest of the math world now reads. 9 expert mathematicians double-checking one AI's math. Reassuring or a little unsettling. Genuinely curious which way you lean. It didn't stop at 9 mathematicians reading it over either. The disproof was also formalized in Lean, a proof assistant that checks logic mechanically, step by step. That's a second, independent layer of verification with zero room for a human to miss a subtle error. And here's the part that actually matters most for what this means. The AI's construction wasn't the final word. Within weeks, human mathematicians substantially improved on it. The model didn't finish the problem. It kicked the door open and humans walked straight through. So no, this isn't AI replaces mathematicians. It's a model finding a doorway between two fields no human had thought to connect, then handing it off. The follow-through, the improvement, the peer scrutiny, that part is still entirely human. Worth clearing up a mix-up, this isn't the same kind of AI math story as AlphaGeometry or AlphaProof. Those solve already known Olympiad problems, with the AI itself formally checking its own proof. This was a genuinely open research conjecture, with the checking done afterward by humans and lean. Different tool, different kind of solved entirely. Now the honest part nobody puts in the headline. Killing Erdős' specific bound doesn't tell anyone the actual true growth rate. That's now a fresh open question. And one striking result doesn't mean the model can do this kind of cross-field leap reliably on command. It still took expert humans to pick this result out, verify it and translate it. That step didn't disappear. If humans still have to verify, rewrite and improve the result, who actually gets credit here? No clean answer. What's your honest take? Let's fold the whole case back together. The mystery, an 80-year-old guess about how many unit distance pairs points can pack. The mechanism, an unreleased OpenAI model reached into number theory to build the counterexample. The catch, 9 mathematicians and a proof assistant had to check it before anyone trusted it. An 80-year-old guess broken by a model that hadn't even been publicly named yet. The true answer is still unknown, which honestly makes this more interesting, not less. Do you think this is real mathematical creativity or a very lucky search? Tell Kuro below and subscribe.